The manager of a coffee shop has one type of coffee that sells for $5 per pound. Let's think of it as this kind of dark coffee here. So that costs $5 for every 1 pound. And another type that sells for $12 per pound. So we can think about that as being this lighter colored blend here. So it's $12 for every 1 pound. The manager wishes to mix 40 pounds of the $12 coffee to get a mixture that will sell for $9 per pound. How many pounds of the $5 coffee should we use? So in case the verbiage isn't quite clear, we know we've got 40 pounds of $12 coffee. We know that in total the mixture is going to cost $9 per pound. So we need to find an unknown poundage of this $5 coffee. And the best way to approach this problem, well, I guess any problem really, but in particular we really need to be careful when we think about our units. So let's start building a nice algebraic expression here. And I'm going to preserve all the units. So 40 pounds worth of some coffee that costs $12 for every 1 pound, right? To that, we're going to add an unknown quantity, let's say x, again in pounds, x pounds of some coffee that cost $5 for every 1 pound. We add those things together, what do we get? Let's think about what we've got here. We have, for both of these terms, you want to think about it this way, a certain poundage times a price per pound. Mathematically, we can be crossing out these units here. What we've got, really, is we're taking a dollar sign and we're adding it to another dollar sign. We have got something that represents money over here. But what do we actually need on the other side? We've got to complete this somehow. We know we're going to be working with the term $9 in 1 pound. We need that term to be very closely related to this somehow, right? But if we just try and solve this equation the way it is, this 40 times 12 over 1 plus x times 5 over 1 equals 9 over 1, it's not going to work. Because over here, you can see the units are in dollars, and over here, the units are in terms of dollars per pound. So we have to wipe out the pounds somehow. But let's think about this. What you do when you take a bunch of spoonfuls like this, a bunch of spoonfuls like this, each worth a certain certain amount per spoonful, what we've got is a total cost, right? The total cost of this kind of coffee plus the total cost of this kind of coffee. How do we express that on this side? Well, over here, there's a certain amount of poundage. When multiplied by $9 per pound, that's going to be equal to the total cost of the blend of the bag of coffee. What is that poundage that we're looking for? We know it has to be at least 40, but it's actually 40 plus x pounds. Total poundage times the amount per pound cancels out the poundage, and we're good with our units. We have basically only dollar signs left, so a dollar sign 40 times 12 plus dollar sign x times 5 equals dollar sign 40 plus x times 9. And of course, you know, the dollar signs are kind of extraneous. I don't really want to think about units when I'm doing math. It's my habit anyway. Anyway, if we work towards solving this thing, what we're going to get is x, which is going to represent the amount of pounds, just like it appeared originally, of, you know, brand X, our dark colored coffee that we need. So the 40 times the 12, that's going to turn into 480 plus 5 times x. I'm going to distribute the 9 into this 40 plus x, and we'll get 360 plus 9x. At this point, I can think about isolating my x's by gathering them together. So I can subtract 5x from both sides, and that'll leave me with 480. Let me give myself a little bit extra room here. This process will leave me with 480 equals 360. 9 minus 5, so positive 4x is left over there as those cancel out. And now I can subtract 360 to get the numbers by themselves, and we'll get this thing 120. Now 120 is going to be equal to 4x, so that we can divide both sides by 4 and find that x is equal to 30. 30 pounds of our dark colored coffee up there is exactly what we need to get this blend that's worth about $9 per pound.